So good afternoon all. So let's start with this week's tutorial, right? So this tutorial solution is actually available on Moodle. You can find it under week four's, under week four's notes, right? It's there. So in this week's tutorial, we'll be basically focusing on, again, recapping on Nyquist and Shannon's theorem, and we'll be paying a little attention on the harmonics of a particular signal, right? So problem number one, the following sequence is transmitted through the communication channel, right? So there's a set of bits that are given over here. If the transmission was done in 35 milliseconds, find the data rate. So data rate is basically given as the rate of transfer of the data, right? So it could be also mean number of bits per second, right? Isn't it? So data rate is number of bits per second. So that is what is written over here. Data rate is basically equal to a number of bits per duration or time duration. So which is also equal to the number of bits being transmitted in the total number of time, right? Isn't it? So we are transmitting how many bits, right? If you pay attention to this, right? If you count the number of bits over here, we have 1, 2, 3, 4, 5, 6, 1, 8, 9, 10, 11, 12, 13, 14. So we are transmitting 14 bits in 35 milliseconds. So in order to find the data rate, what we need to do is we need to divide this number of bits that is being transmitted, that is 14 bits, divided by the total time taken to transmit this number of bits. So 14 bits divided by 35 milliseconds is going to give me 400 bits per second. Okay. So usually data rates are given in bits per second, right? You might have seen your internet speeds, your have you noticed this? Like whenever we are given the data speeds, it is usually in megabits per second or kilobits per second. But the standard unit is BPS, right? While the mega or kilo just represents the prefix of the value or the amount of data being transmitted. Have you noticed it, guys?
Yeah.
Yeah. Okay. So that was regarding the regarding part 1A. Part B, a communication system is using multiple levels to transmit information. If the channel bandwidth is determined at 28.57 hertz, and the maximum data rate is that of part A, find the number of levels being used, right? So what this indicates is that we are told that the channel bandwidth is given, right? So channel bandwidth is basically equivalent to 28.7, right? That is given over here. So this is channel bandwidth, right? That is given in the question. It also says use the maximum rate given in part A of this equation, of this question, right? So what is the maximum data rate that is given in part A? The maximum data rate is 400 bits per second. So we need to find the number of levels required, right? Number of channels required or number of levels that is being used in this particular communication system. So we go back to our Nyquist theorem. So the Nyquist theorem uses the number of channels, right? So the Nyquist theorem is basically C is equal to 2b log of base 2 of m, where m is the number of levels required, isn't it? So we need to find m. We already know our bandwidth, right? We know our bandwidth that is given in our question, plus the maximum data rate becomes my channel capacity, okay? The maximum data rate is basically my channel capacity. So the channel capacity is basically equivalent to whatever value you got in part A as per the question. So in part A, we got 400 bits per second. So that becomes my channel capacity. So based on the Nyquist equation, right, we know our capacity, we know our bandwidth. What else do we need? Any other value? No, right? We just need to know our capacity and our bandwidth in order to calculate M. So what we do is we try to make m the subject of the formula, right? Making m the subject of the formula, we get m is equal to 2 to the power of c upon 2b, right? Then what we need to do is we just directly need to substitute the bandwidth, this particular value over here, 28.57, and the channel capacity over here, that is 400, to find our m value. So basically, when you evaluate, you'll get m is equal to 128. Okay, is that fine?
Yes.
Okay, this part is basically what I mean. In this particular question, once you get once you have made m is equal m the subject of the formula, you can calculate c upon 2b. So calculating c upon 2b, which will be 7, right? You'll get 7. So then what we need to do is, in order to find m, whatever value you get for c upon 2b, you just raise it to 2 to the power of that particular value. So in that particular case, you're getting m is equal to 2 to the power of 7, and m 2 to the power of 7 is basically 128. So we require 128 levels in this particular communication system. All right. Moving on to part C of this particular question. On part B, find the SNR. If the systems have the same bandwidth and capacity, right? Same bandwidth and same capacity, we just need to find our SNR. So the SNR is basically used in our Shannon's theorem, isn't it? So just hold on. Yep. So based on our previous question, right, same as part B, in our part B, we were given the bandwidth as 28.57 and our channel capacity as in part A, which is 400 bits per second. So we know our bandwidth, we know our capacity. Now we need to calculate our SNR. So SNR is basically given by the channel capacity, the bandwidth, and the SNR is basically related to our channel Shannon's capacity theorem, which is basically given by C is equal to B log of base 2 of 1 plus SNR, right? Now we know our C, we know our B value. We need to find SNR. So what we do is make SNR the subject of the formula, right? If we make SNR the subject of the formula, we'll get SNR is equal to 2 to the power of C upon B minus 1. Okay. So we get SNR is equal to 2 to the power of C upon B minus 1, right? And in order to find SNR in dB, since it states, right, SNR in dB, isn't it? So SNR should be given in decibels. So in order to convert this SNR value will be absolute value, okay? So in order to convert this SNR into dB, what we need to do is take 10 log of the SNR value, isn't it? So we know SNR is basically equal to 2 to the power C upon B minus 1, right? This is what our SNR is. In order to get convert SNR into dB, what we need to do is take 10 log of this particular value, right? 10 log of 2 to the power C upon B minus 1. And since we know our capacity, that is 400 bits per second, and bandwidth as 28.57, we can calculate our SNR. So if we calculate our SNR, we'll be getting SNR in dB as 42.14 decibels, okay? Is there any questions regarding this particular question number 1? I mean, so far? So far, do you have any question? Sorry, your mics are muted at the moment, okay? Do you guys have any questions so far?
All clear.
Okay. Just in case if you need any clarification, please just pause me in between and you can ask, right? In part D, it says in a binary system, a bit stream is coded using 16 levels, right? So let's highlight that 16 levels. If the carrying capacity of the system is 10 gigabits per second, find the bandwidth of the system, right? So we are given the number of levels. So number of levels is basically equivalent to our M. Okay, this over here is basically equivalent to our equal to our C. Okay, So we know M and we know C. In order to find B, what do we need? This is related to the Nyquist theorem, isn't it? So going back to our Nyquist theorem states that C is equal to 2B log of base 2 of M. Okay. So we know our M, we know our C. We just need to find our B. So B, making B the subject of the formula, we'll be getting B is equal to C upon 2 times log of base 2 of M. Okay. So we just directly need to substitute the values. C is basically 10 gigabits per second. So 10 times 10 to the power of giga is represented by 10 times. Giga is basically represented by 10 to the power of 9, isn't it? So that would be capacity becomes 10, right? 10 is the value times 10 to the power of 9. That is what we have. 10 times 10 to the power of 9 bits per second divide by 2 times log 2 of M, right? So basically 2 times log 2 of 60. Okay. So if we evaluate this particular value over here, okay, we'll be basically getting log 2 of M, which is equivalent to log of M upon log 2, right? If you go back to your go back to your logarithmic properties, 2 to the power of, let me just quickly write the theorem. So there's a okay, some of the logarithmic properties are a to the power of b is basically equivalent to c. So taking logs on both sides, I'll be getting this b comes in front, isn't it? B log a is equivalent to log c. You remember this property? This b comes in front, take log of both sides, so you'll be getting b times log a, which is equal to log c. Okay, this is one of the properties. The other property is the base property, right? So this same thing can be written as in terms of log. It would be taking logarithmic of base a of c is going to give me b. So that is log of c of base a is basically equivalent to b. Okay, so based on this, right, based on this, oh sorry, where is it? Sorry. Okay, that's what we get. Now, if you pay attention to this particular equation over here, you can see that log 2 to the power of m is going to give me some c value, right? Some b value. Okay, so this indicates m is my solution. M is equivalent to my c. This 2 indicates is equivalent to my a. Okay, which is equivalent to b. Okay, now in order to find b using this particular property, b is basically equivalent to log c divided by log a, isn't it? So log c divided by log a. So in this particular case, m is equivalent to my c, 2 is equivalent to my a. Okay, so we are looking for b. So b is basically equivalent to log a divided by log c, log c divided by log a. So basically log m divided by log 2. Okay, these two properties. Using these two properties, we can find our log of m of base 2, right? We can evaluate this particular part. So log 16, m value is 16, right? Log 16 divided by the base value is 2, so log 2, which gives me 4. Okay, so basically this part is given as 4. So that is what we write over here, right? So 2 times 4, okay, which is going to give me a bandwidth of 1.25 gigahertz. So everyone is okay with this? Sorry about my writing
Sure.
again. Yes.
Yeah, excuse me. So
Yeah.
that means this log, the log at the denominator,
Mhm.
this log 2 is of base 10.
No, this log 2, this small log 2, I mean this 2.
No, the one down. Log
This.
16 upon.
Oh, yes. This indicates of base 10. Okay. All
Okay,
these
yeah.
logs that I'm using, these logs are of these logs are of base 10. Okay. I
Okay,
think,
thank you.
yeah. Also, the other thing is, let me just quickly recheck this. Okay, this, in place of these logs, you can also use the ln function. Okay, in place of these logs, you can also use logarithmic or natural logarithmic functions as well. It is going to give you the same value. Okay, the ratio, since this is a ratio, isn't it? So since this is a ratio, even if you use the ln function, it is going to give you the same result. You can recheck. Okay. So when we are writing log without a base, like this log over here, in this particular case, when I wrote this subscript a, so this indicated of, I mean, taking the logarithmic of base a. Okay.
Yes.
But when I don't write any subscript, it is basically an indication I'm using just the base of 10.
Base 10.
Okay.
Yeah.
So you are okay with this, right? Sorry about this. This forms one whole function, and this is another whole function. Okay, just in case, I believe you should be knowing these logarithmic properties, but just in case if you are not clear with these logarithmic properties, you can directly drop a message in the group and I'll find it, like, no, I'll write it down clearly and send it to you guys. All right. So that's regarding the logarithmic properties that is being used, right? Now, moving on. So based on that, we can find our bandwidth, right? Based on this particular formula, we have our C value, that is 10 gigabits per second. And we know our M value, right? So directly substituting the values in this particular equation. So we get C as 10 times 10 to the power of 9 bits per second, right? This 10 to the power of 9 basically represents giga. Holding upon taking this 2, bringing it over here, and log of 16 of base 2 is basically equivalent to 4, right? That has been evaluated over here. Directly it's substituting the values. Our bandwidth is basically equivalent to let me just directly recheck. Is it 6 or 1? So 10 times 10 to the power of 9 divided by 8. So this is basically equivalent to 1.25, right? This is 1. This is not 6, okay? 1.25 gigahertz per second. Now, moving on to question number, part 2 of this particular question. Part 2 of this particular question says, we need to find SNR in dB for a channel with the same bandwidth, right? Same bandwidth and same capacity. So now what happens is we go back to the Shannon's theorem, right? We know our bandwidth, we know our capacity. We just need to find SNR in dB. So we have already found the formula in this part, right, of the question. Sorry, in this particular question. So SNR in dB is basically equivalent to 10 times log 2 to the power of C divided by B minus 1. So you can use the same particular formula, right? Taking that same particular formula, we know our bandwidth, right? Bandwidth is given as 1.25 gigahertz that we calculated, right? 1.25 gigahertz. And our capacity is now the same capacity given over here, that is 10 gigabits per second. So we know our B, we know our C, right? We can evaluate SNR dB. So directly substituting the values, you should get 24.06 decibels. Okay, it's direct substitution. Yes. Do you have any questions? So that completes our question number 1 of this tutorial. Anyone has any questions? Okay, let's move on to question number 2. Right. Problem number 2. 1. a binary transmission system uses 8-bit word encoding system. Find the bandwidth and the SNR dB of the system if the channel capacity is 19,200 bits per second. Assume the bandwidth of the channel to be the same as the noise-free channel. Okay, so based on this, the system is of 8 bits, right? So if it's of 8 bits, what happens is we can find our number of levels. So number of levels is basically 2 to the power of n. So our 8 bits, this 8 bit is an indication of n value, right? So m is basically equal to 2 to the power of n, right? Or 2 to the power raised to the number of bits. So m is basically equivalent to 2 to the power of 8, which is equal to 256 levels, right? That's how we get 256 levels. Then our bandwidth, right? Our bandwidth in the SNR dB, we need to find this if the channel capacity is 19,200 bits per second. So we can directly get our bandwidth. We directly get our capacity value from the question itself. This is our bandwidth. This is our capacity. We need to find our bandwidth. So based on this particular value, we have already calculated our m value. Based on this particular value given in the question, we have our capacity value, right? So we have our m and we have our c. So this reflects to our Nyquist equation, isn't it? So Nyquist equation says c is basically equivalent to 2b log 2m, right? So based on this particular equation, we can find our b, isn't it? Since we know our c, we know our m, right? M was calculated based on the number of bits that was given over here. So now we just need to make b the subject of the formula. Making b the subject of the formula, we get c, right? This is the subject of formula. This is the same equation that we can use, right? B is basically equivalent to c divided by 2 log of base 2 of m. So using that particular equation, we can evaluate our b, right? So in this particular equation, what happens is log 2 of m is basically equivalent to log 2 of 256, which is equal to 8, right? Okay. So what this indicates, 2 to the power of 8 is basically going to give me 256, isn't it? So log 2 of 256, if you substitute the m value over here in this particular case, that is 256, this particular part is going to give me 8 as the answer, isn't it? So that becomes 2 times b times 8 is equal to c. So our capacity is basically equivalent to 19.2 kilo, right? 19.2 kilo or 19,200 bits per second divided by 2 times 8 is 16. So B is basically equivalent to C divided by 16, which is equivalent to 19.2 K divided by 16, which gives me 1,200 hertz, right? So you can evaluate this using this method, or you can directly use this equation that you have got and directly substitute the value. So in this particular case, our capacity was 19,200 or 19.2 kilohertz divided by 2 times log 2 of 256. Okay, so log 2 of 256 is basically equal to 8. So 8 times 2 is 16. So that means B is basically equivalent to C divided by 16. So that is how you get C divided by 16. Okay, so based on this particular case, we have calculated our bandwidth, right? Now we need to calculate our SNR in decibels. So calculating our decibels, SNR in decibels, we have found the equation in this particular case over here in part C of question number 1. We made SNR. We formed the formula for SNR in dB, right? This is the formula. So based on this, we know our capacity from the question. We have calculated our bandwidth. We just need to substitute the value to get our SNR in dB. Okay, so going back to this particular question over here, we know our bandwidth, right? This is our bandwidth, and our capacity is this, right? So making SNR dB the subject of the formula, or directly substituting the values in that particular formula that I showed you, you'll get 48.16 dB. Or what you can do is you can reevaluate the formula, right? If you make SNR the subject of a formula in the Nyquist equation, sorry, in the Shannon's equation, you'll get SNR is basically equivalent to 2 to the power of C divided by B minus 1, right? Whatever value you get, right? In this particular case, you'll be getting 65,535, and find 10 log of this particular value to get our SNR in decibels, right? So will you be able to solve this? Guys,
Yes, sir.
will you be able to solve this? Okay.
Yeah, I
See,
think so. Sure.
okay, if you want, this is the similar steps that we did, right? So if you take this B, right, you take this B to the other side, you divide by B, isn't it? So that's how you
Yeah.
get C divided by B, right? So this will form C divided by B. So you'll be left with C divided by B is equal to log 2 to the power 1 plus SNR, right? Isn't it? So this 2 indicates the base. This is my answer. So what raised to the power of 2 is equivalent to my answer? So basically that is 2 to the power of C divided by B is going to give me 1 plus SNR, isn't it? So that is how we get 2 to the power of C divided by B, okay? And then taking this 1, right? Once you have 2 divided by C, 2 to the power of C divided by B, you are just left with 1 plus SNR. So taking this one the other side, you get minus 1, isn't it? So that's how you are left with SNR is equal to 2 to the power of C divided by B minus 1. So then you directly take this bandwidth, take what the bandwidth value and the capacity value, right, from the first part of this question, and substitute it into this particular formula over here. You should get a SNR value of this particular value over here, and take 10 log of this answer. This 10 is times, right? 10 times log answer. 10 log 65535. Okay, that's how you get 48.16 decibels. Now moving on to question number 3. Question number 3, or problem number 3. A periodic signal is used in a binary communication system. The Fourier expansion of the signal is given by the equation. This is the equation that is given over here, right? Okay, forget about whatever is written over here. So this is the equation that is given over here. And it says n is equal to 1 and all the odd values of n, right? So it starts with 1 and all the odd values. So that indicates 1, 3, 5, 7, and so forth, right? No even values are there. Okay. So this is a particular signal's Fourier transform. The Fourier equation or Fourier expansion is given by this particular equation over here. Now, based on this equation, you can see that this is in form of r e to the power of j theta. So this particular coefficient, this particular value over here, is my magnitude, isn't it? R e to the power of j theta, isn't it? You remember Euler's representation or polar form?
Yeah.
Yeah. So it's in this particular form. So this becomes my magnitude, okay? Or amplitude. If I'm talking about magnitude, magnitude is also the amplitude, isn't it? So now reading on to the rest of the question, it says if the amplitude of the signal is 10 volts, right? If the amplitude of the signal is 10 volts and the periodic is 20 milliseconds, find the amplitude of the first and the third harmonic. So what this means, the first and the third harmonic, right? If you list it down, the number of harmonic, so all the n values, right? All the n values are listed over here. It starts with 1 and it goes up till, it keeps on going, isn't it? Till infinity. So it goes on till infinity. The definition of n is equal to 1 is basically the first frequency or the first component will be the fundamental frequency, isn't it? So first part is the fundamental frequency, right? And then the second one will be the first harmonic, okay? So 1 is when n is equal to 1, it is going to give me the fundamental, right? The fundamental frequency. When n is equal to 3, that is when my first harmonic will occur. When n is equal to 3, when n is equal to 5, the second harmonic will occur. When n is equal to 7, the third harmonic will occur. So that means when n is equal to 9, my fourth harmonic will occur, and so forth. Okay? So you just create a table for that, right? Quickly, because that's how we get the harmonic, right? This n times 2 pi f naught t, this indicates the harmonic part, isn't it? N times f naught. This is my harmonic. So the f naught is basically my fundamental frequency. When you are multiplying by n, so when n value is 1, I'll get my fundamental frequency, isn't it? So that is why 1 is equal to my fundamental frequency. And then it also says all my n values are in odd numbers, okay? So when n is equal to 3, that is when my first harmonic will occur, okay? Now it says find the amplitude of the first and the third harmonic. So we just need to find our amplitude. So amplitude is basically given by 8 times a, right? 8 times a divided by n times pi to the power of 2, okay? So this is the formula for my amplitude. So amplitude is basically equivalent to 8 times a divided by n times pi whole thing to the power of 2, right? So, excuse me, this a, right? This a is equivalent to 10 volts, right? From the question. So if a is equal to 10 volts, right? My first harmonic will occur at n is equal to, from this table, n is equal to 3. So to find the amplitude of the first harmonic, in place of n, substitute 3. So amplitude of first harmonic is basically equivalent to 8 times a. A is the amplitude of the signal, that is 10 volt, right? This is my a. So 8 times 10 divided by my n value will be now 3. Okay. So n is equal to 3. So 3 times pi to the power of 2. So 8 times 10 will basically give me 80. Okay. This a value is 10. Okay. This is where we get this a value from. So a is equal to 10. So 10 times 8 is going to give me 80. And my first harmonic occurs at 3, right? When n is equal to 3. So 80 divided by 3 pi whole thing squared is going to give me the amplitude of the first harmonic, right? Which is equivalent to 0.9. Same way you evaluate for the third harmonic. So third harmonic will occur. This amplitude won't change, right? So 8 times 10. So basically that is 80 divided by the third harmonic will occur at n is equal to 7. So when you substitute n in n is equal to 7 over here, so that will be basically 80 divided by 7 times pi squared, right? So that is what we get over here. 8 times 8, so 8 times 10, that is 80, divided by 7 times pi whole thing squared, which is basically equivalent to 49 pi squared, is equal to 0.165. Okay, so this is the amplitude of the third harmonic. This is the amplitude of the first harmonic. Okay, so is that fine? Is that fine, guys? Okay, great.